Hello, good afternoon, everyone. Welcome to our very first DNA Microsoftware conference. And this is J.R. Joseph Gabanada, and I will be presenting you today our talk in today's conference. So today's conference, I'm going to be talking about, a loop back to the title of our talk for today is a loop back to asynchronous. Why is it the title of our talk for today? You know, this talk is specifically for intended for our, not only for our tenured developers, old developers. Um, this is also for our new developers and software engineers out there, and especially if we are using JavaScript. Uh, you know, we've been using this feature, the asynchronous feature of JavaScript, and all throughout our projects and our codes. But this is a topic that is most often than not, this is more often overlooked um, with the developers out there, because this is a new feature in JavaScript, which is in ES6. Uh, when we talk about asynchronous, we don't usually dig deep into the word. We just go ahead and just code and use the feature async, and then we have not dig deep or dive into what it really means and what is the deep root meaning of it and how it really works. And today I'm going to be showing you the probably the most basic and the root um, essence to it. That's why it's called a loop back. It's a rewind to things that we have overlooked in the past and regarding asynchronous operation. I will be teaching you right about that today. So let's begin. And specifically, the programming language that we're going to be using, I would expect that majority of the viewers that we have are using JavaScript as their programming language in their projects and their codes, and I would expect most of us already know how to use it, and we are JavaScript developers. So first thing that we have to know when we use JavaScript, we use it in our browsers. And we have this so-called JavaScript runtime in our browsers. And because JavaScript runs on our browsers, and one of the browsers that we are using most people is in Google Chrome. It's called the V8 engine. It's the engine that runs on our Chrome browsers. That those are the engines that runs the JavaScript code that we have, the program that we have. In Google Chrome, we have V8 engine, and then in Mozilla Firefox, we have SpiderMonkey. And then this is the engine that the Mozilla Firefox use, and there are others, which is the Internet Explorer, which is kind of insignificant for us to discuss today. So before we dig into the asynchronous, we still need to tackle one piece of information, which is all these JavaScript runtime JavaScript engines that we are using is running on a single single-threaded. What does single-threaded means? This is a really important thing we have to understand in order for us to understand how asynchronous really works. So what is a single-threaded? A single-threaded operation is executing one statement at a time, and we will be discussing about that more later on. So it executes one statement at a time, executes one code statement at each time, okay? So let me give you a brief example on what single-threaded means. Let me just switch this. So let's say, imagine that we are in a restaurant, and our there's a kitchen. We have a waiter at table 2 and table 1. That's our customers, table 1 and table 2. And our waiter is most probably our JavaScript runtime. Um, if we are using a single threaded operation, there's only one waiter that talks to all the customers, and the waiter and then goes to the kitchen and then goes back to the customers and then goes back to the kitchen. There's only one waiter. There's also another way to do that, which is multi-threaded operation. Multi-threaded operation is, again, we are in a restaurant. There's a kitchen. There are customers, table 1 and table 2, waiting. However, there are multiple waiters that could accommodate our customers at the same time. Waiter 1 could accommodate the one that you customer in the table 2, and then waiter 2 can at the same time accommodate those in table 1, and waiter 1, waiter 3 could just wait for another customer. So in this way, the waiters could accommodate real time, simultaneously all the customers in the restaurant. Compared to the single thread, there's only one waiter that is working to all the customers around. You see the difference using in single-threaded and multi-threaded. That is how our JavaScript engine works. Our JavaScript engine is single-threaded operation. It's not multi-threaded operation. There's only one statement. There's only one waiter. There's only one that works each time. So it's very important for us to understand that. So next up, we will be discussing what synchronous is. So in our setup, we have a setup in our restaurant. So the yellow circle is our waiter, and then the blue one is our kitchen. There are 2 customers or 2 tables that we have. For our synchronous operation, in a single-threaded way of operating things, there's only one waiter. We have to take note of that. There are 2 ways that the waiter could accommodate the customers. So one way is that the waiter could go to the first customer, and then, let's see, goes to the kitchen, and then goes right back to the go back. The waiter goes to the customer, takes the order, and goes to the kitchen, prepares the food, and then goes back to the customer, and then goes to the next customer, and then takes the order, goes to the kitchen, and then he kind of takes one customer at a time. Like when you there's a difference in that, and we compare it to the asynchronous operation. When we look at asynchronous operation, the waiter takes the order and then goes to the kitchen while it is still preparing, goes to another customer and then takes the order and prepares the food, and then takes the order of the first customer and takes it back to the first customer. You kind of get a point. So let's look at the definitions. It is very important to look at the definitions that we have. So when we say asynchronous, synchronous has a prefix called a, which means without or not. So that is asynchronous. And synchronous means occurring at the same time. So asynchronous means occurring at the same time. Which means asynchronous, if we combine those words that we have, it means not occurring at the same time. It's pretty simple. And then the synchronous, if we break down the word, syn comes from Greek, which means together, and chronos means time. So chronos, we get the word time. It means together in time. If we kind of understand the word, it means together in time. While asynchronous is not together in time. Okay? Like, let's say, for example, in we say conversation, we speak about conversation and we look at asynchronous. It means the conversation is happening at the same time, occurring at the same time. One-on-one conversation is a synchronous conversation. It means it's a real time. If I communicate my words to my partner, I have to wait for his response automatically, and I do not speak unless I receive a response. That's a real-time conversation. While, asynchronous, when we speak about asynchronous, one great example for that is an email. Email is a great example for asynchronous conversation. Say, for example, when you write an email to your client, you send the email, but you do not expect your client to respond immediately. Or a voicemail, when you try to call someone, you leave a voicemail and not expecting someone to call you, not expecting someone to, automatically return the call. The opposite side of the conversation could just call you back. They can call you back at their own time. That's what it means to be asynchronous. Okay. All right. So now that we've understand pretty much the concept of asynchronous and synchronous operation, we are going to dig right deep into the JavaScript runtime environment. Okay. All right. So are you guys ready? So our JavaScript runtime environment has these elements inside of it. We have the source code, we have the memory heap, we have the web APIs, we have the event loop, we have the callback queue, we have the call stack. And let me just ask you this. JavaScript runtime environment is different from our JavaScript engine. Our JavaScript engine is inside our JavaScript runtime environment. So let me just ask you one question. Which of these elements that we have in our environment, by the way, this is in Chrome. This is in our browser. This can be found in our browser. But our browser houses the JavaScript runtime. And which of these elements is included in our JavaScript runtime. Let me try to guess. I'll give you like 2 seconds to guess which of these elements are included in the JavaScript runtime, which is V8. And to give you the answer, this is our JavaScript runtime, and on the left side is our V8 JavaScript engine, and then the answer to the question that I gave you earlier is that our JavaScript engine only includes the memory heap and the call stack. All right, it does not include. This is something that we don't know before, and it's been of a shock to me that the V8 JavaScript engine does not include the web API and callback queue and even the event loop, and it is outside the JavaScript engine. The JavaScript engine only has two elements, two parts: the memory heap and the call stack. We will be discussing about that later on. I will be discussing to you each of the elements right now. Even right now, we will discuss. So let's say we have this on the blue one on the bottom left corner. We have our source code. This is JavaScript runtime includes our source code, the program code that we have, and then let's see, we have web APIs. It's an API that only is added by our browsers. It goes to the HTTP request. It's outside our V8 engine. It's the HTTP request, the timers, our fetch function, the event listeners. I've always thought that event listeners and the DOM API was included in the JavaScript V8 engine, but it's not. It's outside of V8 engine. It's in the web API. It's within our browsers, but it's specifically added by our browsers, which is Chrome. And then we have the event loop and callback queue. And in order for us to further understand how the asynchronous operation that we have been using most of the time in our programming daily, and then we need to understand how the JavaScript runtime environment works. Okay, so let me give you a brief overview of what is happening on the outset. There's a source code. We have the const, the variables that we have, and then we have functions in our codes, and then all of that, if you might have known, it is stored in the memory. It's called the memory heap. The memory heap stores all that variable as part of memory heap, function declarations, and you might have wondered where all those const variables and let variables are stored in the memory heap. And our call stack, this is where we're going to be focusing on later on. Call stack is part of the V8 engine. It is LIFO, last in, first out stack. From the word stack, it stacks all the functions in our source code. It accepts every function in the source code. It is synchronous. This is the one that we've been talking about, that our V8 JavaScript engine is single-threaded, so it accepts one statement at a time. So it is synchronous. So our V8 engine, using the call stack, looks to our source code, looks to every statement of our code, and then looks at it and puts it in the call stack, stacks the code, and runs those statements at a time. Each one statement at one time. It is synchronous and one function at a time in its stack. And then we have our web APIs. Our web APIs include our HTTP requests, set timeouts that we have, our fetch, our event listeners, like get element by ID, or on click, or hover, and especially also the DOM API. And we will also be talking about the event loop, which is really essential to our understanding with using our asynchronous. We have a callback queue. Callback queue is a queue which stores all the callbacks. We'll be discussing about that later. And it has a FIFO, which is first in, first out data structure, which means that the things that goes into our callback queue is going to be the one that's going to be executed or go out to our callback queue. All right. So let's say, for example, we have a function called bar, and then we have a function set timeout in it, and a console log set timeout for about 500 milliseconds, and then executes those function bar foo and math. We have this call stack. Take a look at the call stack. Let's just wait until it goes back to the beginning. We have bar and then set timeout. Set timeout is one of the if we go back here, set timeout is one of the function that the browser offers, gives us, and it is one of the web API of our JavaScript Runtime Environment. Once set timeout is executed, it goes outside of our V8 engine and goes to our web API. If we look at it, you see, we have the bar, and then it executes the set timeout. Set timeout goes to our web API, wait for those function, for a timer to operate. Then that timer goes to our queue, and then the event loop runs, goes to our call stack. So what is happening here is that each of our function is executed each statement at a time. First is the bar, goes in the stack, and then looks at the function. He sees the set timeout. Execute this set timeout, which is a web API function. A web API function goes to the web API, and then it has a console log. Set timeout, gives a timer, which is 500 milliseconds. Execute those timer in the web API, and then once the timer runs out 500 milliseconds, it then lets go of the console log that we have. It does not execute the console log yet. It goes to the queue. And then once the call stack is empty, our event loop then runs and then execute the very first thing that pops up in our callback queue, which is our console log. All right? And that is pretty much how the asynchronous operation works. And I think that wraps up our talk for today. And I hope you guys learned something for today's talk when we discussed about the asynchronous operation. It's not that much. We have dig a little bit deeper to what the asynchronous operation is, how it works under the hood. And I hope that we have come to understanding how this thing works, and we will be more expert how to deal with asynchronous operations in our code, in our programming daily, and then in our project. will be using more efficiently this kind of asynchronous operations. And hope to see you soon for on further and more topics that we are going to be discussing to you and here at DNA Microsoftware. And uh, if I'll take the time to please we have a YouTube channel. You can subscribe to our YouTube channel, watch our monthly webinars and monthly um, talks about all kinds of stuffs in our development. And we'll be talking about a lot of great things in the future, and we are so excited for it. This is our first talk for you know for the first time since forever, and we're planning to have more talks in the future, and hope to be seeing you there on our next talks. Once again, this is JR, and uh, software engineer here at DNA Micro Software, and happy